Hello, in this lecture we'll find out the value of angle ADC using two different methods. In the drawing we have triangle ABC. We know that angle ABC, this angle equals to 30 degrees. This angle ACB equals to 100 degrees. We also know that side AD equals to side BC. And we want to find out the value of this angle ADC. So we'll start with the first method, and we will define side AC of triangle ABC as A. That is to say, the length of side AC is equals to A units, and we'll define side BC as B. That is to say, the length of side BC equals to B units. BC equals to B units. And we know that AD equals to BC. It is given us in the question. And according to our definition, BC equals to B units. So from this equation, AD equals to BC equals to B, we will derive that AD also equals to B. In the next step, I will present to you a new law, and we will implement the law in our drawing. The new law is the law of sines. And the law of sines is true in any triangle. So in any triangle, if you have triangle ABC, that could be any triangle. This is triangle ABC. And we know that side BC of triangle ABC equals to A units in its length. This is angle A. We also know that side AC of triangle ABC equals to B units in its length. And this is angle B. And we know that side AB of triangle ABC equals to C units in its length, and this is angle C. Then, according to the law of sines, A over sine A equals to B over sine B. Equals to C over sine C. C over sine C. I'll repeat again. In any triangle, A over sine A equals to B over sine B equals to C over sine C. From this formula we will derive that A over sine A equals to B over sine B. Okay, A over sine A equals to B over sine B. And we will implement the law of sines in our triangle ABC. But first of all, we will find out the value of this angle BAC. So I will copy triangle ABC in a new page, and we will find out the value of angle BAC, and then we will implement the law of sines in this triangle ABC. So this is a triangle ABC that I copied from the original drawing. We know that side AC equals to A units, side BC of triangle ABC equals to B units, angle ABC equals to 30 degrees, and angle ACB equals to 100 degrees. So according to the law of sines, we will get that first of all, we will find out the value of this angle BAC. So we will define it as angle X. And we know that the sum of the angles in any triangle is equal to 180 degrees. So especially in triangle ABC, the sum of its angles must be equal to 180 degrees. That is to say, angle X so the sum of the angles in triangle ABC equals to 180 degrees. That is to say 30 degrees plus 100 degrees plus angle X must be equal in total to 180 degrees. We will subtract from equation number 1 130 degrees, and we will get that so we will subtract 130 degrees from this equation number 1, and we will get that angle X equals to 180 degrees minus 150 degrees is 50 degrees. So we found out that angle X equals to 50 degrees. I will substitute angle X by 50 degrees. In the next step, we will implement the law of sines in this triangle ABC. according to the law of sines, A over sinus 30 degrees equals to B over sinus 50 degrees. Here we will divide the question number 1 by B, and then we will multiply it by sinus 30 degrees, and we will get that A over B equals to sinus 30 degrees over sinus 50 degrees. In the next step, we will implement the law of sines in triangle ADC. But first of all, we have already found out that angle BAC, this angle, equals to 50 degrees. So if we define angle DAB, this angle is angle theta, then 50 degrees minus theta must be equal to this angle. So angle DAC will be equal to 50 degrees minus theta. Okay, and if we define the angle that we are looking for, that is to say angle ADC as y, then we know that the sum of the angles in triangle ADC must be equal to 180 degrees. So that is to say angle y plus 100 degrees plus this angle that is actually equals to angle DAC equals to 50 degrees minus theta. In total, the sum of those three angles must be equal to 180 degrees. Here we will subtract 150 degrees from this equality, from this equation, and we will get that y minus theta equals to 180 degrees minus 150 degrees is 30 degrees. Here we will add angle theta to this equation, and we will get that angle y equals to 30 degrees plus theta. So the angle that we are looking for is actually angle ADC that equals to angle y equals to 30 degrees plus theta. So I will substitute angle y by 30 degrees plus theta. In the next step, I will copy triangle ADC in a new page, and we will implement the law of sines in this triangle, triangle ADC. So angle DAC equals to 50 degrees minus theta. So I copied triangle ADC in a new page, and we will implement the law of sines in this triangle ADC. We know that side AC equals to A units, side AD of triangle ADC equals to B units, angle DAC equals to 50 degrees minus theta, angle ACD is given as that it equals to 100 degrees, and angle ADC, the angle that we are looking for, equals to 30 degrees plus theta. So we will implement the law of sines in this triangle ADC. According to the law of sines, A over sinus 30 degrees plus theta equals to B over sinus 100 degrees. Here we will divide the equation number 2 by 2, we will divide the equation number 2 by B, and then we will multiply it by sinus 30 degrees plus theta, and we will get that A over B according to equation number 2 equals to sinus 30 degrees plus theta over sinus 100 degrees. Okay. So here we will cross multiply, but before that, actually, this is equation number 2, and according to equation number 1, we have already found out that A over B equals to sinus 30 degrees over sinus 50 degrees. So we have two expressions for A over B, so we will create equation number 3 that states that A over B according to equation number 1 must be equal to A over B according to equation number 2. Okay? So A over B according to equation number 1 is sinus 30 degrees over sinus 50 degrees. And it equals to A over B according to equation number 2, that is to say it equals to sinus 30 degrees plus theta over sinus 100 degrees. So repeat again. Equation number 3 states that A over B according to equation number 1 equals to A over B according to equation number 2. Here we will cross multiply equation number 3 and we will get that first of all sinus 30 degrees is 1 over 2, so I will write it down. 1 over 2 times sinus theta times sinus 100 degrees equals to sinus 30 degrees plus theta so it equals to sinus 30 degrees plus theta times sinus 50 degrees. And we will use the trigonometric identity that states that sinus 2a equals to 2 sinus a cosine a Okay, we will use the trigonometric identity that states that sinus 2a equals to 2 sinus a cosinus a, and according to this trigonometric identity we will get that sinus 100 degrees will be equal to 2 sinus 50 degrees cosinus 50 degrees. Okay, so according to the trigonometric identity that sinus 2a equals to sinus a cosinus a, we will get that sinus 100 degrees equals to 2 sinus 50 degrees times cosinus 50 degrees. So according to this trigonometric identity, we will get that sinus 100 degrees equals to 2 sinus 50 degrees cosinus 50 degrees, and it equals to sinus 30 degrees plus theta times sinus 50 degrees. Here 2 over 2 will get cancelled, and we have sinus 50 degrees on both sides of the equation, so sinus 50 degrees will get also get cancelled. And we're left only with the equations that state that sinus 30 degrees plus theta so we found out that sinus that cosinus 50 degrees according to equation number 3 So according to question number 3, cosinus 50 degrees equals to sinus 30 degrees plus theta. Here we will use the trigonometric identity that states that cosine alpha equals to sinus 90 degrees minus alpha. According to this trigonometric identity, we will get that cosine 50 degrees according to this trigonometric identity, we will get that cosine 50 degrees equals to sine 90 degrees minus 50 degrees. And that is to say cosine 50 degrees equals to 90 degrees minus 50 degrees is 40 degrees. So we found out that cosine 50 degrees equals to sinus 40 degrees. And we actually can substitute cosine 50 degrees in question number 3 by sine 40 degrees, so we'll do it now and we will get that according to question number 3, cosine 50 degrees that equals to sine 40 degrees equals to sine 30 degrees plus alpha. Again, sine 40 degrees equals to sine 30 degrees plus alpha, 30 degrees plus theta. Sine 40 degrees equals to sine 30 degrees plus alpha means that 40 degrees equals to 30 degrees plus alpha plus theta. Here we will subtract 30 degrees from this equation and we get we subtract 30 degrees from this equation and we get that angle theta equals to 10 degrees. Okay, so we found out that angle theta equals to 30 degrees, but the angle that we are looking for is angle ADC that equals to 30 degrees plus theta, and 30 degrees plus theta is 30 degrees plus 10 degrees, that is to say angle ADC equals to 40 degrees. So we actually found out that the angle that we are looking for, that is angle ADC, equals to 40 degrees. We finished with the first method. In the next step I will present to you how to find out the value of this angle, angle ADC, according to the second method. In the second method, we will define side BC of triangle ABC as A, that is to say the length of side BC is equal to A units according to our definition. But according to what is given us in the question, AD equals to BC, and according to our definition, BC equals to A. So from this equation, AD equals to BC equals to A, we will derive that AD also equals to A. AD equals to A, so we can write here that AD equals to A. In the next step, we will extend side BC by a straight line. And from point A, we will draw perpendicular to the extended BC. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we will define the intersection point from the perpendicular from point A, and the extended BC as point E. Again, the intersection point between the perpendicular from point A and the extended BC is defined as point E. And we find out the value of this angle, angle ACE. Actually, BC is one side of triangle ABC, therefore it is absolutely a straight line. And when we extended the straight line BC by a straight line, we got line segment BE that must be also a straight line. So we write down that line segment BE is a straight line. BE is a straight line. And we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if you focus on the upper side of the straight line BE at point C, then the sum of the angles must be equal to 180 degrees. So if we define angle ACE as Y, then according to the rule that I mentioned, 100 degrees plus angle Y must be equal to 180 degrees. Here we will subtract 100 degrees from this equation, and we will get that angle Y equals to 180 degrees minus 100 degrees is 80 degrees. So we found out that angle Y equals to 80 degrees. So we can substitute angle Y by 80 degrees. In the next step, we will define side AE as Y. That is to say, AE equals to Y units in its length. And we will define side CE as X. That is to say, the length of side CE equals to X units. And then we will focus on the right triangle, triangle ACE. On the right triangle, triangle ACE, We know that tangent 80 degrees equals to AE over CE. I repeat again. In the right triangle ACE, tangent 80 degrees equals to AE over CE. According to our definition, AE equals to Y and CE equals to X. So actually, according to equation number 1, tangent 80 degrees will be equal to Y over X. I repeat again. In triangle ACE, the right triangle, tangent 80 degrees equals to Y over X. Here we will multiply equation number 1 by X, and we will get that Y equals, what is the equation 1? Y equals to X times tangent 80 degrees In the next step, we will focus on triangle ADE, the right triangle ADE. But first of all, we will define the angle that we are looking for, that is to say angle ADE is angle theta. And in the right triangle ADE, we know that sinus theta equals to AE over AD. Again, in the right triangle ADE, sinus theta equals to AE over AD. I repeat again, in the right triangle ADE, sinus theta equals to AE over AD. But according to our definition, AE equals to Y and AD equals to A, according to what we have already found out. So actually, we found out that sinus theta, according to equation number 2, equals to Y over A. I will repeat again. According to equation number 2, in triangle ADE, sinus theta equals to Y over A. So according to equation number 2, sinus theta equals to y over a. Here we will multiply equation number 2 by a, and then we will divide it by sinus theta, and we will get that according to equation number 2, a equals to y over sinus theta, but according to equation number 1, y equals to x times 80 degrees, so we'll substitute y by x times 80 degrees, and we will get that according to equation number 2, a equals to x times 80 degrees over sinus theta. And according to equation number 1, y equals to x times 80 degrees. In the next step, we'll focus on the right triangle, triangle ABE. On the right triangle, triangle ABE, tangents 30 degrees equals to AE over BE. I will repeat again. In the right triangle, triangle ABE, tangents 80 degrees equals to AE over BE. But according to our definition, AE equals to y, and BE equals to A plus X. So according to equation number 3, we will get that tangents 30 degrees equals to y over a plus x. I'll repeat again. According to equation number 3, tangents 30 degrees equals to y over a plus x. Here we will substitute y by x tangents 80 degrees, and we will substitute a by x tangents 80 degrees over sinus theta. Okay, and we will get that according to equation number 3, tangents 30 degrees equals to y is x tangents 80 degrees according to equation number 1 over a plus x. A according to equation number 2 equals to x tangents 80 degrees over sinus theta. Plus x. Here we will multiply x by sinus theta, and then we will divide it by sinus theta, so we change nothing. So here we will move sinus theta from the denominator to the numerator, and we will get that running to equation number 3, tangents 30 degrees equals to x tangents 80 degrees times sinus theta over x times 80 degrees plus x sinus theta. So here we have x in the numerator and we have x in the denominator, so x will get cancelled. And we also know that minus 30 degrees equals to 1 over square root of 3, so I'll write it down. According to equation number 3, minus 30 degrees equals to 1 over square root of 3, and it equals to minus 80 degrees times sinus theta over minus 80 degrees plus sinus theta. Here we substituted minus 30 degrees by 1 over square root of 3 units. We got this expression. So here we will cross multiply equation number 3 and we'll get that minus 80 degrees plus sinus theta equals to square root of 3 times 80 degrees times sinus theta So here we will subtract sinus theta from this equation, equation number 3, and we will get that minus 80 degrees equals to square root of 3 times 80 degrees times sinus theta minus sinus theta so here we'll take sinus theta as a common factor from this side of equation number 3 and we'll get that minus 80 degrees equals to, and sinus theta is taken as a common factor, so inside the brackets we have here square root of 3 times minus 80 degrees minus 1. Here we'll divide this equation by square root of 3 times 80 degrees minus 1, and we'll get that according to equation number 3, sinus theta equals to times 80 degrees over square root of 3 times 80 degrees minus 1. So here we will substitute tangent 80 degrees by sinus 80 degrees over cosine 80 degrees, and we will get that sinus theta according to equation number 3 equals to tangent 80 degrees is sinus 80 degrees over cosine 80 degrees over square root of 3 tangent 80 degrees is sinus 80 degrees over cosine 80 degrees and the minus 1, we will substitute minus 1 by minus cosine 80 degrees over cosine 80 degrees. And here we have cosine 80 degrees in the numerator, and we have cosine 80 degrees in the denominator, so cosine 80 degrees will get cancelled. And what is left after we cancel cosine 80 degrees from equation number 3, what is left is actually we have sinus theta that equals to sinus 80 degrees over square root of 3 times sinus 80 degrees minus cosine 80 degrees. So here we multiply the denominator inside of equation number 3 by 2, and then we will divide it by 2, so we change nothing, and we will get that sinus theta according to equation number 3 equals to sinus 80 degrees over 2 times square root of 3 over 2 sinus 80 degrees and we divide cosine 80 degrees by 2, so we got that according to equation number 3 sinus theta equals to sinus 80 degrees and divided by sinus 2 times sinus 80 degrees, and we substitute square root of 3 over 2 by cosine 30 degrees because of the fact that cosine 30 degrees equals to square root of 3 over 2 minus, and we will substitute 1 over 2 by sine 30 degrees. Actually, we got in the denominator sinus 80 degrees times cosine 30 degrees minus sinus 30 degrees minus cosine 80 degrees. And this expression is very similar to the trigonometric identity that states that sinus A cosine B minus sinus B cosine A equals to sine A minus B. So according to this trigonometric identity, we can substitute our expression by sine A minus B when A equals to 80 degrees and B equals to 30 degrees. So we'll do it now. And we will get that according to equation number 3, sinus theta equals to sinus 80 degrees over 2 times. We substitute our expression by sinus A minus B when A equals to 80 degrees and B equals to 30 degrees. So we get, instead of our expression, sinus 80 degrees minus 30 degrees. Sinus 30 degrees minus 80 degrees is 50 degrees. So we found out that sinus theta equals to sinus 80 degrees over 2 times sinus 50 degrees. We will use the trigonometric identity that sinus 2a equals to 2 sine A cosine A. We use this trigonometric identity for sinus 80 degrees. And according to this trigonometric identity, we will get that sinus 80 degrees equals to 2 sinus 40 degrees times cosine 80 degrees times cosine 40 degrees over 2 times sinus 50 degrees. Okay, here 2 over 2 will get cancelled. And we'll use the trigonometric identity that sine alpha equals to cosine 90 degrees minus alpha. According to this trigonometric identity, we will get that sinus 50 degrees equals to cosine 90 degrees minus 50 degrees. That is to say, sinus 50 degrees equals to cosine 40 degrees because of the fact that sinus 50 degrees equals to cosine 40 degrees. We will substitute sinus 50 degrees in equation number 3 by cosine 40 degrees, and we get that according to equation number 3, sinus theta equals to sinus 40 degrees times cosine 40 degrees over cosine 40 degrees. So here we have cosine 40 degrees in the numerator and we have cosine 40 degrees in the denominator. So cosine 40 degrees will get cancelled. And we left only with sinus theta that equals to sinus 40 degrees. It means if sinus theta equals to sinus 40 degrees, it means that theta equals to 40 degrees. So we found out that theta equals to 40 degrees, and theta is the angle that we are looking for, that is actually angle ADC, equals to 40 degrees. So we actually found out that the angle that we are looking for, that is angle ADC, it equals to theta. Angle ADC that equals to theta equals to 40 degrees. So in both methods we found out that angle ADC equals to 40 degrees. In the next step I will summarize the lecture. Actually we wanted to find out the value of angle ADC. We found the angle ADC in two different methods. In the first method, we define side AC of triangle ABC as A, we define side BC as B, and we know that AD equals to BC equals to B. AD equals to BC according to what is given us in the question, but BC equals to B according to our definition. So from this equation AD equals to BC equals to B, we will derive that AD also equals to B. Then I presented to you the law of sines. The law of sines is true in any triangle. According to the law of sines, if the length of AC is C units, the length of AC is B units, and the length of BC is A units, then A over sinus A equals to B over sinus B equals to C over sinus C. From this formula we will derive that A over sinus A equals to B over sinus B. Then we implemented the law of sines in our triangle ABC. This is triangle ABC. We know that side AC equals to A units, side BC equals to B units, angle ABC equals to 30 degrees, angle ACD equals to 100 degrees. This is the missing angle. We know that the sum of the angles in any triangle is equal to 180 degrees. So if we define the missing angle as angle X, we will get that X plus 100 degrees plus 30 degrees must be equal to 180 degrees. We subtracted 130 degrees from this equation and found out that angle X equals to 50 degrees. So angle BAC equals to 50 degrees. Then we implemented the law of sines in this triangle ABC. According to the law of sines, A over sinus 30 degrees equals to B over sinus 50 degrees. Then we divided this equation number 1 by B, and then we multiplied it by sinus 30 degrees, and we got that according to equation number 1, A over B equals to sinus 50 degrees over sinus 50 degrees. Then we focused on triangle ADC. But before that, we have already found out that angle BAC equals to 50 degrees. This angle equals to 50 degrees. So if we define angle BAD as theta, then 50 degrees minus theta will be the value of angle DAC. So angle DAC equals to 50 degrees minus theta. And if we define the angle that we are looking for, that is to say angle ADC as y, then according to the rule that the sum of the angles in any triangle is equal to 180 degrees, so in triangle ADC we get that 50 angle y plus 100 degrees plus this angle that is 50 degrees minus theta must be equal to 180 degrees. We subtracted 150 degrees from this equation and we got that y minus theta equals to 30 degrees. We added theta to this equation and we found out that angle y equals to 30 degrees plus theta. So the angle that we are looking for, that is angle ADC, equals to 30 degrees plus theta. Then I copied triangle ADC in a new page and we implemented the law of sines in this triangle ADC. So this is triangle ADC that I copied in this page from the original drawing. We know that the angle ADC equals to 30 degrees plus theta, angle ACD equals to 100 degrees, angle DAC equals to 50 degrees minus theta. According to the law of sines, we will get that A over sinus 30 degrees plus theta will be equal to B over sinus 100 degrees. Here we divided this equation by B and then we multiplied by sinus 30 degrees plus theta and we got that A over B equals to sinus 30 degrees plus theta over sinus 100 degrees. This is according to equation number 2, but according to equation number 1, we have already found out that A over B equals to sinus 30 degrees over sinus 50 degrees. So we have two different expressions for A over B. So we created equation number 3 that states that A over B according to equation number 1 must be equal to A over B according to equation number 2. And A over B according to equation number 1 is sinus 30 degrees over sinus 50 degrees, and A over B according to equation number 2 is sinus 30 degrees plus theta over sinus 100 degrees. Okay, so we cross multiply this equation number 3. We know that sinus 30 degrees equals to 1 over 2. So 1 over 2 times sinus 100 degrees will be equal to sinus 30 degrees plus theta times sinus 50 degrees. Here we use the trigonometric identity that states that sinus 2a equals to 2 sinus a cosine a. According to this trigonometric identity, we will get that the value of sinus 100 degrees equals to 2 sinus 50 degrees cosine 50 degrees. So here 2 over 2 will get cancelled, and it equals to sinus 30 degrees plus theta times sinus 50 degrees. Here we have sinus 50 degrees on both sides of equation number 3, so sinus 50 degrees will get cancelled, and we left only with cosine 50 degrees that equals to sinus 30 degrees plus theta. According to the trigonometric identity that cosine alpha equals to sine 90 degrees minus alpha, we will get that the value of cosine 50 degrees equals actually to sinus 90 degrees minus 50 degrees. That is to say, the value of cosine 50 degrees is 90 degrees minus 50 degrees is 40 degrees, so the value of cosine 50 degrees is sine 40 degrees. Okay, so we can substitute cosine 50 degrees in equation number 3 by sine 40 degrees. We did it and we got that according to equation number 3, sinus 40 degrees equals to sinus 30 degrees plus alpha. Sinus 40 degrees equals to sine 30 degrees plus alpha means that 40 degrees equals to 30 degrees plus theta. It is actually theta. 40 degrees equals to 30 degrees plus theta. Here we subtracted 30 degrees from this equation number 3, and we got that the value of theta is 10 degrees. Theta equals to 10 degrees, but the angle that we are looking for is angle ADC that equals to 30 degrees plus theta. So the angle that we are looking for equals to 30 degrees plus theta, that is 10 degrees. That is to say the angle ADC equals to 40 degrees. The angle that you are looking for is angle ADC that equals to 40 degrees. So we found out that according to the first method, angle ADC equals to 40 degrees. Then I presented to you how to find out the value of angle ADC according to the second method. In the second method, we defined side BC as A. According to what is given us in the question, AD equals to BC, and according to our definition, BC equals to A. So from this equation, AD equals to BC equals to A, we will derive that AD also equals to A. So we can write here that AD equals to A. Then we extended side BC by a straight line, and from point A we draw perpendicular to the extended BC, and we defined the intersection point between the perpendicular from point A and the extended BC as point E. Then we defined side AE as Y and side CE as X, and found out the value of this angle, angle ACE. We know that BC is one side of triangle ABC, therefore it is absolutely a straight line. And when we extended the straight line BC by a straight line, we got line segment BE that is also must be a straight line. So we know that BE is a straight line. And according to the rule that the sum of the angles on one side of a straight line equals to 180 degrees, we will get that if we focus on the upper side of the straight line BE at point C, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. That is to say 100 degrees plus this angle, that is angle Y, must be equal to 180 degrees. Okay, here we subtracted 100 degrees from this equation, and we got that angle Y equals to 80 degrees. So we found out that this angle, angle ACE, equals to 80 degrees. Then we focused on the right triangle, triangle ACE. On the right triangle, triangle ACE, we know that triangle 80 degrees equals to AE over CE. But AE equals to Y, CE equals to X according to our definition. So we found out that triangle 80 degrees equals to Y over X. We multiplied this equation. In conclusion, we found out that triangle 80 degrees equals to Y over X. We multiplied equation number 1 by X, and we got that Y equals to X times 80 degrees. Then we focused on the right triangle, triangle ADE. On the right triangle, triangle ADE, we defined angle ADE as theta, and we know that sinus theta in triangle ADE will be equal to AE over AD. The right triangle, triangle ADE, sinus theta equals to AE over AD. But AE equals to Y according to our definition, and AD equals to A. We found out that AD equals to A. So in conclusion, we found out that sinus theta equals to Y over A. We multiplied equation number 2 by A, and then we divided it by sinus theta, and we got that A equals to Y over sinus theta. But according to equation number 1, we know that Y equals to X times 80 degrees, so we can substitute Y in equation number 2, this equation, by X times 80 degrees. We did it, and we got that A equals to Y, that is X times 80 degrees over sinus theta. This is according to equation number 2, and according to equation number 1, we have already found out that Y equals to X times 80 degrees. Then we focused on the right triangle, triangle ABE. On the right triangle, triangle ABE, we know that tangent 30 degrees equals to AE over BE. on the right triangle, triangle ABE, we know that tangents 30 degrees equals to AE over BE. AE equals to Y. BE equals to A plus X. In conclusion, we found out that actually the right triangle, triangle ABE, tangents 30 degrees equals to Y over A plus X. Here we substituted Y by the value of Y according to equation number 1, and we substituted X by the value of X. We substituted A by the value of A according to equation number 2, and we got that tangents 30 degrees equals to Y, that is X times 80 degrees, over A plus X. A according to equation number 2 is X times tangents 80 degrees over sinus theta plus X. We multiplied X by sinus theta and we divided by sinus theta, so we changed nothing. Here we moved sinus theta from the denominator to the numerator, and we got that tangents 30 degrees equals to X times 80 degrees times sinus theta over X times 80 degrees plus X sinus theta. Okay? Then we know that tangents 30 degrees is 1 over square root of 3, so we substitute tangents 80 degrees by 1 over square root of 3, and we have X in the numerator and X in the denominator, so X will get cancelled. In conclusion, we got that according to equation number 2, 1 over square root of 3 equals to tangents 80 degrees times sinus theta over tangents 80 degrees plus sinus theta. Here we cross multiplied this equation number 3, and we found out that tangents theta plus sinus theta, tangents 80 degrees plus sinus theta equals to square root of 3 times tangents 80 degrees times sinus theta. Here we subtracted sinus theta from this equation number 3, and we found out that tangents 30 degrees equals to square root of 3 times tangents 80 degrees sinus theta minus sinus theta. Here we took sinus theta as a common factor from this side of equation number 3, and we got that tangents 80 degrees equals to sinus theta is a common factor. Inside the brackets we have square root of 3 times tangents 80 degrees minus 1. Then we divided this equation number 3 by square root of 3 times tangents 80 degrees minus 1, and we got that sinus theta equals to tangents 80 degrees over square root of 3 tangents 80 degrees minus 1. Then we substituted tangents 80 degrees by sinus 80 degrees over cosine 80 degrees. So tangents 80 degrees is sinus 80 degrees over cosine 80 degrees over square root of 3 times tangents 80 degrees. So we substituted tangents 80 degrees by sinus 80 degrees over cosine 80 degrees, and we substituted minus 1 by minus cosine 80 degrees over cosine 80 degrees. So cosine 80 degrees will get cancelled because we have it in the numerator and in the denominator also, and we left only with here sinus theta that equals to sinus 80 degrees over square root of 3 times sinus 80 degrees minus cosine 80 degrees. Then we multiplied the denominator by 2, and then we divided by 2, and we got that sinus theta equals to sinus 80 degrees over, we multiplied the denominator by 2 and then we divided by 2, so it is 2 times square root of 3 over 2 plus, times sinus theta, and here we divided cosine 80 degrees by 2. Then we got that sinus theta equals to sinus 80 degrees, 2 times, we substituted square root of 3 over 2 by cosine 30 degrees, and we substituted 1 over 2 by sine 30 degrees. We got the expression that sinus 80 degrees times cosine 80 degrees minus sinus 80 degrees times cosine 80 degrees is very similar to the expression that, to the trigonometric identity that sinus A times cosine B minus sinus b times cosine a equals to sinus a minus b, when a equals to 80 degrees and b equals to 30 degrees. So we substituted our expression by sine a minus b when a equals to 80 degrees and b equals to 30 degrees. And we got that sinus theta equals to sinus 80 degrees over 2 times sinus a minus b, that is actually sinus 80 degrees minus 30 degrees. 80 degrees minus 30 degrees is 50 degrees. So in conclusion, we got that sinus theta equals to sinus 80 degrees over 2 times sinus 50 degrees, because 80 degrees minus 30 degrees is 50 degrees. And then we use the trigonometric identity that sinus 2a equals to 2 sine a cosine a in order to simplify the expression sinus 80 degrees. So according to this trigonometric identity, we will get that sinus 80 degrees equals to 2 sine 40 degrees times cosine 40 degrees. So in conclusion, we got that sinus theta equals to 2 sine 40 degrees times cosine 40 degrees over 2 sine 50 degrees. Then we use the trigonometric identity that states that sinus alpha equals to cosine 90 degrees minus alpha. And according to this trigonometric identity, we got that sinus 50 degrees equals to sinus 90 degrees minus 50 degrees. 90 degrees minus 50 degrees is 40 degrees. So in conclusion, we found out that sinus 50 degrees equals to cosine 40 degrees. Therefore, we can substitute sinus 50 degrees in the denominator of equation number 3 by cosine 40 degrees, because they are equal to each other. And in conclusion, we got that sinus theta equals to sinus 40 degrees times cosine 40 degrees over cosine 40 degrees. Cosine 40 degrees over cosine 40 degrees is 1, so it will get cancelled. And we left only with sinus theta that equals to sinus 40 degrees. Sinus theta equals to sinus 40 degrees means that theta equals to 40 degrees. So we found out that angle theta equals to 40 degrees, and that is actually the angle that we are looking for, because of the fact that angle theta equals to angle ADC. So angle ADC that equals to angle theta equals to 40 degrees, and we found out that the value of angle theta in both methods is equal to 40 degrees. Okay, thank you very much.